So, hi again, everyone. It's Mr. Rooney, and we're going to start our section here on Chapter 9, referring to inequalities. So, inequalities, as you might know, are going to be a little bit different than equalities, of course. So, things that are not equal, where one side does not equal the other. A couple of skills that we're going to have to acquaint ourselves with, and we'll get to that here. We're going to have to represent inequalities verbally and algebraically and also graphically. So we'll get to that and give you some examples of what those things look like. I just want to point out in your textbook here, there's a couple of important sections. Certainly here, referring to what an inequality is, we might have a look at that using the symbols. And as well, if we get to the next page on the top of 342, this table right here is very, very important. It'll help you understand your symbols. If we don't know our symbols, we're in a pile of trouble. And also as well down here, this literacy link helps us understand that we have, what verbally looks like using words, graphically using a number line, and algebraically, of course, using our friend the x and a value and of course a symbol there. So we'll get to a couple of examples that I've drawn up to help you through this. Just again to review what our symbols look like. Greater than. That means whatever is over here is greater than whatever is over here. Less than. This is greater than or equal to. This means that we could have something that's bigger than, or it could also be the same. So a situation where we might see that is, you have to be 16 to get your driver's license. You could be exactly 16, or you could be bigger than 16. And then the last one, of course, is less than or equal to. Situation where that might apply is where we have a speed limit. You have to travel. Your speed over here has to be less than 90, could be equal to 90, and you're okay. All right? So those are some terminologies that might help explain that. More than or bigger than. Some other ways to represent each of these. No less than, the same or bigger, minimum at least for the greater than or equal to. And finally, no more than, you can travel no more than 90, or you can travel the same as 90 or smaller, or you have a maximum. So those kind of extra terminologies may help you a little bit with the vocabulary. So here are a couple of different examples. To represent verbally here, we have Kara. Maybe we'll do this so we don't get too much to look at. Kara has no fewer than 15 Facebook friends. No fewer. So what does that mean? Does she have 15 Facebook friends? Well, she sounds like she's got at least. So another way to say that is at least 15. So her Facebook friends would be X. We have 15 here, and we want to show no fewer than 15. So could it be 15? Yes, it could be 15. Could it be more than 15? Of course, she's got no fewer. So she can't have less than 15, but she could have exactly 15. Now, how would we represent that on our number line? Well, we're going to show from 15 all the way out this way, right? She's got more than 15, but she also has exactly 15. And exactly 15, we're going to use a closed circle. More about that in a second. A closed circle shows us that we want to include the 15. Just another example, Tom has to run less than 4 minutes a mile to break the school record. So again, algebraically, we have to run less than 4. So there's his time, X. It's got to be less than 4 minutes. Can it be equal to 4 minutes? Doesn't sound like it. Sounds like it's got to be less than 4 minutes to break that mile. So in that case, we're going to show, here's 4. We want to show everything less than 4. And this time we're going to use an open circle. An open circle, such as that, tells us that we're not including 4. We can include up to 4, but we can't include the 4. We use an open circle in that situation. Now, to represent verbally, how could we represent these things verbally? All right. Well, we might say a number or numbers greater than 75. That would work. Or we might say more than 75. That would work. Over here, we might say a number less than or equal to negative 98, right? We might say no more than negative 98, or can't exceed, or maximum. Now, we're typically reading from left to right because we see where the x is. But so in a case like this x less than 8, sorry, x greater than 8, right? So we would say, a number that is more than or bigger than 8. Well, what would happen if we had the x on the other side? What would happen if we did this to it? I'm going to spin that around. We haven't changed the problem. All we did, we spun it around. We're still, if we read it now this time, this way. Let's talk about that. We're going to read from x, and we read it this way. Even though that's a less than sign, we typically will read from left to right. But now if we read from right to left, we still have, let me put it for you this way. How about 8 is less than x, or a number? 8 is less than x. Well, if 8 is less than x, that means that x is more than 8. And that takes some thinking. Those are equivalent. You gotta really stew on those a little bit. Okay. Now we're going to take you over to do some practice at creating these. This is probably the trickiest part, but it's kind of the fun part too. We're going to create these graphically or with number lines. So a couple of notes to remember again. An open circle, we do not include. A closed circle, we do include. Okay? So here's our inequality that we're going to try to graph. The 5 is called the boundary point. Boundary point. And that's going to be when I would typically put that right in the middle. So I make, a few on either side. You could fill it in if you wanted, or maybe not make such a large graph. So we want to show all the numbers that are less than 5. All right, so less than 5, of course, is going to go this way. Now, I want to include 5 or not include 5. That's the question. It says less than 5. I don't want to include 5. So if I don't want to include 5, I'm going to pick an open circle. So let's take this guy and just drag it over here. There. Perfect. So I've shown x, all the numbers over here, all the numbers here on the red line are less than 5, and I'm not including 5, so I use that open circle. Let's try another one. Now this one I've intentionally sort of put in the reverse. Now you may struggle with this to read it, but we would read this way. We would say x, we would say x, and if we read it, less than -2. Now if you're desperate to spin that around, you could rewrite the problem so long as you do this. If we have x and -2, so long as you reverse that fellow. If you really need to read it from left to right, we would do that. X less than -2. All right, so I'll put a couple of values on here. -2 is called what? That's called the boundary point. All right, so I want all the values that are less than -2. So I'll be going this way. And I want an open or a closed circle. Let's check back up here. Closed circle includes. I don't want to include because I don't have the line. So I want it. Oops, come on there, fella. I want to not include the -2, right? So I'd use an open circle on that one. All right, this time I have x greater or equal to 12. 12 is my boundary point. Fill in a couple of values on either side. Let's this time figure out whether we're going to do open or close first. I see that I want to possibly include 12. So I'm going to have a closed circle this time. I want to include the 12, and I want to show everything that is, in this case, bigger than 12, right? Bigger than or equal to 12. So I've got everything up here, all that's bigger than 12, and I want to include the 12 as well. Maybe to sign up for soccer, you have to be at least 12. Something like a situation like that. Now, let's go the reverse way. Let's try to interpret algebraically what graphically this may be showing us. Well, can we pick our boundary point? Should be able to pick our boundary point. Pretty easy to pick up. And let's go with x. And we have our boundary point. Now, what are we showing? Are we including the 7? We've got a closed circle, so we're going to include the 7. And we're going in this direction, so we want everything that's bigger than or including 7. Okay, we got to make sure we check our circle pretty carefully. This guy, here's our boundary point. No big problem picking that up. There's negative 13. We're going to use x. And this time we have an open circle, so we don't want to include 13, but we want everything this way. We want everything less than negative 13. Another way, just to throw a hiccup into this, another way to think of that is all these guys are less than negative 13. Other way to think of that, I should say, is negative 13 is bigger than all these guys. Negative 13 is bigger than all of the x values, right? That's another way to look at that. That's a possibility. Okay, this we're going to talk about combining. We have nothing in here, as you can see, but we have something here, and we have something there. So let's figure out this guy first. So here we would say our boundary point is 4, and x is less than 4, but not equal to. So x is less than 4, and we have combining two inequalities. On this side, our boundary point is 8. We have x. X is bigger than 8, but also including 8. Okay? So there's what we call combining inequalities. Okay, combining. It meets two different criteria. So the value could be less than 4, or it could be bigger than or equal to 8. And just one more along those lines. This one's kind of neat. I'm going to put, we have two boundary points here, as you can see, negative 3 and 1. I'm going to put that like this. I'm going to put my x in the middle. This is a different one. So here's all my x value in here, right? And if we read it from right to left, if we think about it this way, x is bigger than negative 3. So think of all this stuff as x, right? X is bigger than negative 3, but x is smaller than or equal to 1. So think about what x could be. X could be anything in here. Well, anything in there is smaller than negative 3, and it's also, bigger than negative 3, and it's also smaller than or equal to 1. So things we want to make sure we check the boundary point. We check whether it's an open or a closed circle. We keep those things in mind. And then the direction is a little bit important. So when I read that, I read it from x bigger than, I'll shade it in here, x bigger than negative 3. So it's got to be bigger than negative 3, but also smaller than or equal to 1. Okay, so that's it for now. Just a little introduction to section 9.1. Hope it goes well. And thank you for watching.